So here we are recording a cell. This is a plant cell, Elodea, that we're looking at under a microscope. Now, what I've done here is I've drawn here around the cell to give you an idea of exactly where this cell is that we're looking at. And these little things that are floating around inside, those are chloroplasts. Remember, chloroplasts are where photosynthesis actually occurs. And so we're seeing the movement of these chloroplasts inside of the plant cell, Elodea, and you can see that they're floating around in the cytoplasm, and it's really moving, and it's a fluid-like substance where this motion is happening inside the cell. So what we're going to do next here is I'm going to go ahead and add some salt water to this. And the salt water, what's going to happen is if I add salt water, okay, so let's just say I'm going to add salt water, okay, to this surrounding area. The salt water, the water inside of this Elodea is going to chase the water out of the cell, because salt water has sodium and chlorine, which both dissolve in water, and these are charges. And so water is going to always chase the charges out of the cell, and it's going to go straight out of the cell. And what should happen is the cell membrane and the cell should shrink, but this cell wall should remain the same. So we will actually see a shrinking where all of these chloroplasts will become tightly packed together. And so here we have our salt water that's been added, and these particles have moved across. And you'll see, I'm going to go ahead and erase our line, but you'll see that our cell wall is still there. And so I will go ahead and draw real quickly our cell wall here. Well, let's use a smaller marker. Let me undo that. And I'm going to quickly draw our cell wall through here. Here we have it all along there, coming down around here, moving up across there, and there we go. It follows all the way down here. And so what has happened is, with all that salt water coming through here, our actual cell has started to shrink. It's no longer pressing up against the cell membrane. You'll see there, and I'm going to change colors here. There is our cell membrane right there, moving across here, and the cell membrane is actually shrunk and pulled away from the cell wall, and we have lost Turgor pressure on the inside of the cell. And so it is very important to note here that this shrinkage has happened because of the salt water pulling the water out of the cell and into the cell membrane. Now you'll notice here, and I'm going to zoom through this, and you can see all the chloroplasts now as I'm rotating through the cell using my fine adjustment on my microscope. You can see all the chloroplasts are really tightly packed now inside of the cell. They're all in here and tightly packed. There's one right there. Switch to a smaller size. There's one right there. I'm going to switch colors too. I'm going to go back to I'm going to go to pink just to outline. But there's one right there. There's another one that's pretty obvious right there. And so they are now tightly packed, and they're no longer moving around freely inside of the cell. But the real thing here is that the cell itself has lost its rigidity, meaning that there is no pressure in this direction up against the cell wall, because the cell membrane has pulled away from the cell wall due to the loss of water from the inside of the cell. So it has actually shrunk down, and we've lost the pressure up against the wall. And so when you look at the two, if I was to compare the two, you would definitely say that this plant is wilted because there is a loss of water pressure, or Turgor pressure as we call it, inside of the cell. Okay, so here we have the cell, and it is a little bit, this has been quite a few minutes now where I've let this sit here in the salt water, and you'll see that the cell has even shrunk further. The inside has gotten even more compressed, and so here we have our cell wall on the outside, this black line. That's still our cell wall. Nothing's changed there, but our cell membrane, the gatekeeper, what goes in and out, has shrunk even more. You'll see the blue line is the cell membrane. And I've highlighted some of the chloroplast in here with green that's circled. And I want to, again, emphasize one more time that the chloroplast are the guys with the little circles, the stacked pancakes on the inside, called thylakoids, but they're stacked inside, and it looks like a bunch of stacked pancakes. Now, you really can't see that very well here, and it's because we don't have a strong enough microscope. But what we're looking at here is, again, mainly turgor pressure and how much further this has now shrunk from the cell wall. So here we're looking, the cell membrane has shrunk this far from the cell wall. Clearly, this plant is wilted at this point, because there is no pressure up against the cell wall from the vacuole. And so the vacuole itself probably started out to be really, really big, something like this, a huge vacuole, and it eventually went to something like this, very small. That caused all this to shrink down and pull away from the cell wall, and this is probably a good 15 to 20 minutes since I have placed the salt water, which has moved across the microscope in this direction. So the salt water moved in this direction. I placed the salt water on this edge right here of the slide, and it has moved in that direction, and you can see that the cell membrane and the cell itself has shrunk, but the cell wall, which is right here, has remained intact, and we have lost turgor pressure. Okay, that is it.